Hello, everybody. I'm Robert Hawes, CEO and founder of Obsidian Research, and today we're going to be taking a look at penetration testing as a service for Android APK mobile testing, and we're going to be looking at a conceptual front end for an orchestration system to fully automate security testing for Android APKs. This includes static analysis, dynamic analysis and runtime, and also mobile API testing itself. And the backend I've already built. So the actual infrastructure, the AVD environment, the build environments for where you're able to upload the APK, do testing of code and all that stuff. All of that already exists in the backend. This front end is just a conceptual idea of what it could look like for a business who's trying to either build this internally themselves, or if you're a third-party security testing company and you're looking to offer a type of service to a customer, you could offer them something along this line. Now, if you're not familiar with orchestration systems are essentially just fully autonomous, end-to-end, no human in the loop automation of a specific operation within a business, or even beyond that. It could automate most activities in a business as long as the orchestration system is designed properly to solve for, having its own ability to perform evaluations of its output to confirm its validity, having the ability to self-learn and improve, having the ability to handle context drift. All of the problems you experience in a normal business, strangely enough, are similar problems you'll face when building an orchestration system as a whole. And I cover more of this idea of orchestration systems and I even demo autonomous end-to-end application development for APKs in a previous video where I go over IntelliGox, which is a multi-platform, multi-product, end-to-end development system, orchestration system, with no human in the loop, right? And in that video, I go over a lot of details about the problems I faced and the theory behind how I developed it and why I went the path I went. Now, today's focus is more centered around cybersecurity, mobile security testing, automation, and what that could actually truly look like. So essentially, if we go ahead and log in, let's log into an example account here. This orchestration system, as of today, is built under the understanding that there's still going to be a human in the loop verifying output, right? So in classical settings, this used to be the business develops an APK, they reach out to a third-party security testing team. That third-party team then uses a mix between scripting for automation and also manual testing to identify vulnerabilities in the product that relate to impacting either the customers themselves, which could then lead into legal fines, could impact the business directly, and all of that was normally a couple weeks, 2, 3, 4 week testing, and then you're given a single final report, and then you have debrief calls, remediation sessions, and it can go on for weeks. A 2-week test could turn into a month and a half, 2 months. From start to fully end, from demo call, kickoff, alignment, scoping, all of that. The idea with this is to kind of like centralize all of that into a single location to where internally within the business, what they used to have to extend to third parties, they now have that same capability internally with an orchestration system that finds the same style of vulnerabilities and even more than the classical manual approach. And if we look at this as like from an operator perspective, when you log in, you see meaningful information, right? So you're on enterprise plan, you have 2 active assessments running. This assessment here, Acme Pay merchant applications and static manifest analysis stage, the Acme Pay consumers and dynamic exploration, recently published findings. So you see the project it's related to, how long ago it's been there, the status for it, is it open? Is it just pending a retest? All of this is here for the operator to be able to manually look at and test. So if we look at an example, let's look at some more data here. So projects, If you're developing more than just one APK, you can have all of these uploaded here as well for testing. Let's look at an example project findings. So let's look at this. Hard-code API secret and res value secrets.xml. You have the action. The operator can mark this as fixed and then upload a new APK to test and verify the retest. This can be all integrated into their CI/CD pipeline directly. The integration is not that, I would say, difficult. You can literally just prompt the agents to build out that pipeline for you and add it into the orchestration system itself. So, as far as like getting functionality to work, that capability is extremely easy nowadays. But from this perspective, when you run an APK through the pipeline, the same findings and report style you get out of a classical penetration test is the same thing the orchestration system is able to create, right? So you'll have a critical, the associated CWEs, CVSS scores, status, open, remediated, fixed, and all that. The assessment ID of where this is linked to, the time it was published, the version of the application it was testing, and then it leads into the description, right? So the high-level overview, the orchestration system creates all of this data for us. None of this is hard-coded, right? And this is really built with the idea of trying to really visualize what the future could be for security. And who knows, maybe in the future, none of this really even exists if the base models just keep increasing rapidly in capability. But as of today, if we're looking at what was classically done and trying to translate classical behavior into an orchestration system for autonomous security, then this might be similar to what you get. So you'll have a description of the vulnerability. The application bundle ships a base64 encoded API key under the resource name API secret key. Any party in possession of the APK can extract it. The key is sufficient to authenticate against the production payments APIs, the application's identity, bypassing per user authentication for endpoints that key the app rather than the user. So this is an interesting part here. So, we're able to take the finding from static analysis. We found this secret key, and the system will be able to dynamically verify that against the mobile APIs itself, and then build proof, evidence, proof of concepts, reproduction steps, and that's what it leads into next, right? Category, sensitive data exposure, gives you the exact component. Evidence. So right now in this front end, this is a conceptual visualization. But if you were to run the same thing at the back end, all of this data, all of this evidence is all in the back end environment already. So you see the output from the different commands, how we went from beginning to end and got the vulnerability working, right? We were able to exploit it, and this is how we did it. That's important because you're trying to tell the full story from, we started from here, we went to the next stage, and then boom, we're here. This is the exploit being triggered. This is the impact. Being able to see that with the orchestration system is important for validation, not only for itself, but for trust in the system for the operator. Reproduction steps, these are classical too in the previous manual testing approach. You follow these steps, and then you're able to come to the same conclusion. We can expand upon this with this output for reproduction to actually include full excerpts of commands executed. It's literally just prompting the system to change itself, and it will. Next, you have the impact. So an attacker who possesses the APK, which is everyone with a Play Store account, can authenticate to the Acme Pay payments API as the application. While this token cannot execute per user actions, it can read service health endpoints, and depending on backend configuration, may expose enumeration of users, fee schedules, or payment network metadata. A leaked key in a public APK has historically been an entry point for full account compromises and similar incidents. So we're also able to look at the impact itself, right? So we have this Acme Pay payments API situation. This is just V1 Health. And it's able to then basically say, like, hey, here's a vulnerability description. Here's the components it's related to. Here's the actual evidence of why we got to this conclusion. Here's the reproduction steps that you can do yourself to get back to the same conclusion we came to. Here's an impact analysis. And then here's remediation for how to fix it. And now, this is all just like demo information that Claude Design created for this, because I asked Claude Design to kind of create this whole front end. So it's important to understand that this can all be modified to however you want your front end to be designed, right? It doesn't take much effort. It doesn't. It's literally just prompting, changing. And if you're using your own orchestration system for full end-to-end development, you just prompt once, walk away, come back, and everything's done. But this concept, this capability already exists, and I demoed it not only with Android APK testing, but also with just normal desktop application like source code projects. The systems are the base models themselves have enough training data to understand how to drive all these tools, right? And so it's up to you to decide how to create your agents, how to create your harnesses, how to create your orchestration system to then build that end-to-end, fully autonomous, no human in the loop evaluation that has actual truthful validation evals to confirm the output. That is the juice. That's the good stuff. And there's a lot more to this too. Like, you can look at reports, retests. This was retested. It's in queue. So 4 hours from now, this will be confirmed and verified. You can look at the organization, different types of roles: workspace lead, developer, security engineering, compliance officer. Why does compliance officer need to have access to this? Well, what if you wanted to look at the audit log? Oh, wait, for example, this is a perfect example. So the current account does not have permissions to read the audit log. So we can sign out of this account, sign into, let's go to compliance. And let's go back to, let's see, organization, audit log. We have the ability to see everything that someone did, right? So we can see their email, the IP where they're connecting from, all of this for compliance reasons and recording purposes. So this is all good information, right? So we can also look at the subscription. So if you're a third party trying to sell this and you want to host it on your own services, you can do this too. But internally, you wouldn't really have this whole subscription thing because this would be just running on-prem. You built yourself. You look at settings. You can set up different things you want to. You have an operator view, and then also let's just go back to the beginning for the cockpit overview. But yeah, this is like, this whole thing here is trying to show and demo like what the future could be for penetration testing as a service. How do you go from just using an existing agent to do source code review to hope that they catch vulnerabilities as pull requests are being committed and all of that. How do you catch all that and then look at taking that even further? Like, how do we automate even more, but also validate itself at the same time to make sure the system actually works? And that's the orchestration. That's the real juice. And so if you're a business and you're curious and you want to talk about these and maybe what your organization is doing already, we offer free consultations. And I highly recommend you look at the other videos I've published as well for not only the example template for the source code analysis orchestration system or basic pipeline workflow, but also IntelliGox as well if you're trying to build your own orchestration system. Because a lot of times, a lot of these capabilities, the frontier labs are moving off of the endpoints into cloud infrastructure behind, where you don't have access to the orchestration. You're allowed to submit data to it and let their orchestration systems operate on your data, but you don't have that same capability internally, right? Because they're going to keep that in the cloud on their own infrastructure, and that's their secret sauce. How they facilitate that orchestration. So that's pretty much it, though. I wanted to kind of like show the demo of the conceptual idea of what a penetration testing as a service platform could look like, whether as a third-party security consulting firm or if you're trying to stand up your own internally in your organization. This is just an idea of what that might look like. And, Once again, my name is Robert Hawes. I'm the CEO and founder of Bacillium Research. And if you have any questions, please just reach out. All right, y'all take it easy.